Welcome to YQ Academy, SQL Interview Questions and Answers. 1. What are the advantages of using stored procedures? 1. Improved performance. Stored procedures are pre-compiled and stored in the database, which allows for faster execution. This eliminates the need to parse and compile SQL statements each time they are executed, resulting in improved performance. 2. Code reusability. Stored procedures promote code reusability by allowing multiple applications or users to execute the same stored procedure. This reduces code duplication and improves maintainability. 3. Enhanced security. Stored procedures can be used to control access to database objects. Users can be granted permissions to execute stored procedures without granting direct access to underlying tables or views. This helps in enforcing security and ensuring data integrity. 4. Simplified maintenance. With stored procedures, changes or updates to the database logic can be made in a centralized manner. This simplifies maintenance and avoids the need to modify multiple application code files. 5. Modular design. Stored procedures allow for a modular design approach, where complex tasks can be broken down into smaller, manageable units. This improves code organization, readability, and maintainability. 6. Transaction control. Stored procedures provide the ability to define and control transactions. Transactions ensure the atomicity, consistency, isolation, and durability asset properties of database operations, allowing for reliable and predictable data modifications. 7. Reduced network traffic. By executing stored procedures on the server side, only the results or required data need to be transferred over the network, reducing network traffic and improving overall performance. 8. Encapsulation of business logic. Stored procedures enable the encapsulation of complex business logic within the database. This helps in centralizing and enforcing business rules, ensuring consistent data manipulation across applications. 9. Performance optimization. Stored procedures allow for query optimization techniques such as query plans, indexing, and parameterization. This can lead to significant performance improvements by optimizing the execution of SQL statements. 2. What is a table called if it has neither cluster nor non-cluster index? What is it used for? A table that does not have either a clustered index or a non-clustered index is called a heap. In a heap, the rows are stored in an unordered structure without any specific sorting or ordering based on the values of the columns. The data is simply stored in the order in which it was inserted into the table. Heaps are used when there is no particular need for data to be physically ordered within the table or when the table primarily serves as a staging area or temporary storage. Here are a few scenarios where heap table might be used. 1. Staging table. In an ETL extract, transform, load process, data may be initially loaded into a heap table before further transformations and loading into the final destination table. 2. Logging or audit table. In scenarios where logging or audit trails are required, a heap table can be used to store the log entries or audit records in the order they are generated. 3. Temporary or transient data. When working with temporary or transient data that does not require indexing or ordering, heap tables can provide a simple and efficient storage mechanism. 4. Bulk insertions. Heap tables can be useful when performing large-scale bulk insert operations, as they do not incur the overhead of maintaining index structures during the insertion process. 3. What are the basic functions for master, msdb, model, tempdb, and resource databases? 1. Master database. The master database is the central controlling database for the SQL Server instance. It stores system-level information such as server-level configuration settings, logins, and metadata about all other databases on the server. It is critical for the functioning of the SQL Server instance and should be regularly backed up. 2. msdb database. The msdb database is used by SQL Server Agent, which is responsible for scheduling and executing jobs, alerts, and maintenance plans. It stores information about backups, job history, and other SQL Server agent operations. It also includes tables and views used for managing database mail, database maintenance plans, and SQL Server Service Broker. 3. Model database. The model database is a template database used as a basis for creating new user databases. When a new database is created, it inherits the characteristics, settings, and objects defined in the model database. Any changes made to the model database will be applied to subsequently created databases. 4. tempdb database. The tempdb database is a workspace for temporary objects and intermediate query results. It is used for storing temporary tables, table variables, cursors, and other temporary storage needs during query execution. It is recreated every time SQL Server restarts and is shared among all users connected to the instance. It is important to size tempdb appropriately to avoid contention and performance issues. 5. Resource database. The resource database is a read-only system database introduced in SQL Server 2005. It stores the system objects that are shipped with SQL Server, such as system tables, views, and stored procedures. It provides a unified view of system objects across multiple instances of SQL Server. Users cannot directly access or modify the resource database. 4. What is Service Broker? Service Broker is a messaging framework and asynchronous queuing technology in SQL Server. It provides a reliable and scalable platform for building distributed and decoupled applications within the SQL Server environment. Service Broker enables you to implement message-based communication between different database instances, applications, or components, allowing them to exchange messages and perform actions based on those messages. Key features and concepts of Service Broker. 1. Asynchronous messaging. Service Broker facilitates asynchronous communication, where sending and receiving components can operate independently of each other. Messages are sent to a queue and processed asynchronously, allowing the sender to continue with its tasks without waiting for a response. 2. Reliable message delivery. Service Broker ensures reliable message delivery by guaranteeing that messages are delivered in order and are not lost. It uses transactional processing and durable storage to provide message durability and reliability. 3. Message queuing. Service Broker utilizes queues to store messages. Messages can be sent to a specific queue and can be received by multiple receivers. Queues provide a reliable and scalable mechanism for handling messages in a distributed environment. 4. Activation. Service Broker supports activation, which allows you to automatically start a process or stored procedure in response to an incoming message. Activation enables you to perform actions based on received messages, such as updating data, executing business logic, or sending responses. 5. Security and authentication. Service Broker provides security features to ensure secure message exchange. It supports authentication and authorization mechanisms to control access to queues and messages. 6. Scalability. Service Broker is designed to handle large volumes of messages and can scale to accommodate high throughput and message processing requirements. It can handle both small-scale and enterprise-level messaging scenarios. This is the end of our SQL interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.